All right, are we good to get started? Yep. All right, so this is Protect Your Payloads, Modern Keying Techniques. I'm Leo. Quick about me, I'm a senior consultant with Protiviti. Execute more on the offensive side, so pen testing, red teaming, that sort of thing. I really enjoy command and control, so I tend to focus a lot of my research around custom implant and tooling around kind of command and control. I casually blog at adaptandattack.com. And just a warning, I'm not a crypto expert. You don't have to worry about any crazy math. But what we do have on the docket today, we're basically going to look at the current landscape of payload delivery and development, kind of see where keying fits in. We'll review how that works, where the advantages are. Then we'll add remote resources to our keyed payloads, and then I'll try and tie it together all at the end here. So I think we can all agree that defense is really getting better. For me, I think it really starts with those endpoint security products, those EDR solutions like your CrowdStrikes, your Carbon Blacks, really adding a lot of visibility to defenders, being able to pick off things that was working really well even a year ago. And that even rolls into just detection capabilities as a whole. Really again, like a year ago, I felt like I was very comfortable getting a payload in an environment and being able to laterally move around, but we're really getting detected more and more. So it's something that we have to start considering and thinking about. Sandboxing, we can argue about whether it's easy to get around sandboxing or not, but it's still something you have to consider when you're trying to get your payload down to the end target. So still increases more cost and more time on the attacker side. There's VirusTotal, there's things in the cloud, there's machine learning. It's just super easy now to just throw a file up in the cloud and it tells you if the file's good or bad. It'll also tell you, different execution behaviors, what servers it's calling back to. Threat hunting is getting more prevalent now. I feel like, defenders are going into their environment and expecting you to be there. So I feel like if I get past those four things, get past all those detection capabilities, get a foothold in the environment, and then a threat hunter comes by and picks off my payload and then kicks me out, I think that's something that we're going to have to start running into as well a little bit more. Innovative tooling, I think blue teams don't get enough credit. They identify their gaps with detection capabilities, then use free tools like sysinternals or Windows Event Forwarding to kind of close those gaps and still be able to detect on things that maybe their current paid-for products can't. And that kind of rolls into improved methodologies. MITRE ATT&CK is really a good step in the right direction. Companies like Red Canary are releasing the ways they write robust detections to essentially detect a little bit better. And I think that just rolls into just general research. There's more blue team talks. There's more researchers on Twitter that are talking about defense. And they're grabbing payloads from VirusTotal and tweeting about and analyzing those and sharing it with everyone. So I think this really just rolls into my main first point. Eventually, doesn't matter how elite you are, you're going to get caught and your code's going to be analyzed if you're doing anything interesting. And why that matters is, like defenders have crown jewels, I think attackers have crown jewels as well. First and most obvious is command and control. So the method that payload's calling back, along with what server it's communicating to. The moment the blue team finds that, there's a good chance they might be able to just get you out of their environment entirely. Initial execution behavior, we're no longer just dropping a single file or executing one process that calls back to our C2. Seems to be there's a lot more links in the chain. So, you're maybe using process hollowing and you're executing that with a scheduled task and with that sort of execution behavior, you feel comfortable getting around an EDR solution. And then, there's some individuals or teams that are even going the more custom implant route. And that's something you want to keep close to your chest during your red team engagement, the whole way through. When I'm talking about, like remote access code or payloads, the scope of this talk is really around phishing. And I think we're really going, we're going with more text-based or scripting languages or C# to kind of execute that first stage of that payload. VBA macros is obvious, something that we've been using, it seems like, for almost 10 years or probably longer. PowerShell is always popular, and obviously the technique there is just stick that PowerShell one-liner everywhere and anywhere and hope it executes somewhere. Now we're getting into JavaScript and VBScript, HTAs, SCT files, extended style sheets. That's allowing those single commands still, those still one-liners that are pulling the code down and executing. And then there's C#, that seems to be the rage now. So MS Build, .NET to JScript to get the power C# within a JavaScript payload. but eventually we want to get into memory, right? So that would be where we maybe use those first 4 bullet items and then try and inject or DLL or shellcode so we can start doing some interesting things. You know, one thing I've been thinking about lately, and something I always think about when I send that first phishing email is, like, what key data points am I really losing the moment I send that phishing email? And, you know, who's going to see those key data points? And, you know, this kind of, you know, one illustration to come up with is a guy on my team basically was like, hey, that's my macro. And what he was referring to was a tweet by John Lambert. Basically, he pulled down a file that he found in VirusTotal, and then he ended up analyzing it and throwing it on his GitHub. And he went through everything. And he went through the VBA. So the VBA was pulling out like a payload from a text box within the Word document, writing it to a temp file, and then executing it with Regserver 32. But then he goes further. He pulls the base64 encoded string within that file, decodes it. And if you're familiar with Empire, it's pretty obvious at this point. It might have been doing some sort of Empire execution. Then if you scroll down further, I mean, there's the domain, the C2 host that it was calling back to, and some other information. So, you know, I don't think the guy on my team, you know, thought that, you know, this payload would be seen by, you know, everyone when John Lambert. He didn't think it would be in a presentation at DerbyCon. So not only did he, you know, did the scope of who was able to see the payload kind of expand, but also he lost a lot of key data points, just not only the C2 server, it was obviously using PowerShell Empire, so if the blue team saw that, they could maybe start looking out throughout their environment, looking for Empire. They found out, you know, where the macro is writing it. So lots of different things that we're just kind of sending in the clear text. And you can find a lot more on Daily Scriptlet. It's not just him. It's, you know, it seems like every day there's some sort of SCT or some other kind of file that is being analyzed. You know, I definitely think obfuscation fits in here. You know, I think that it's a really great technique to defeat those automated solutions that are detecting on certain strings. Can definitely slow down defender analysis. You know, real-world attackers are using the heck out of obfuscation, so definitely something you want to use on every payload that you're sending. Obviously, the disadvantages is if they understand how the obfuscation works, they're going to be able to reverse it and get back to that original source code. And the other thing is if you're not adding any anti-analysis code before you obfuscate, and that payload gets thrown up to like VirusTotal, those execution behaviors, the C2 connections are still going to show up because the payload is still going to execute as expected. Daniel Bohannon has done a lot of great work around obfuscation, same with Ryan Cobb, so definitely some good guys to follow around obfuscation. But we'll kind of switch gears into keying and kind of see where that fits in as well. So how would I kind of describe keying is basically you're encrypting your payloads so that they only execute on a specific target or only execute when you want them to. And if they don't, it's stayed within an encrypted blob. So it's really the idea of encrypting your payloads using local and remote resources to build a decryption key on the target. The main downside is the attacker might have to figure out some of this information ahead of time. So if you wanted to encrypt your payload based on like an environmental variable on the target, you would have to know what that environmental variable was or your payload wouldn't execute. If this sounds familiar, that's because it definitely is. It's not new. Back in 2016, Josh Pitts and Travis Morrow presented exactly about this technique. They really brought this technique to a more practical use case by releasing a tool like Ebola. They talked about different research dating all the way back to 1998, kind of around this, but you know, Ebola was the first you know, real example that brought, you know, the technique to us, really. GOS was a real-world example of malware that used keying back in 2012. And this one, if you're familiar, Kaspersky actually reached out to the industry and said, hey, can anybody please help us decrypt this payload because we can't. So it's definitely super useful. Ebola is still super awesome, works really great. I actually used it a couple months ago, and it did hit up on VirusTotal. Still not a whole lot of detections. I think it was still 0. So antivirus is still having a tough time detecting the payloads. Does a great job encrypting your DLLs, your XCs, your shellcode, and then it kind of gives you an output in a binary that's produced by Go or Python or a PowerShell script. So huge thanks to Josh and Travis for kind of giving us a really first good practical use case for keying. So you're probably wondering, well, why am I here? You know, given the SpongeBob slide in particular, I think keying is needed now more than ever. We really need to protect our code that we're sending down to our targets. And I just kind of I've been using this now for about a year and a half, so I just figured I'd kind of share some experiences, use cases. Most of you guys are probably smarter than I am, so hopefully this will help you guys come up with ways you can use it. Just with talking with people as well about using keying, I feel like a lot of the common responses are, they only understand that it gets around sandboxes, might not understand other use cases. It's a cool idea, but it seems like a lot of work. They don't get it. Or, they're using it a lot and they're just not really talking about it publicly. So I just kind of want to bring it back out here. So I'm going to hit keying at a kind of a more high level. If you kind of want more of an in-depth understanding of kind of how keying works at the payload and code level, definitely take a look at the slides from Josh and Travis. On the Ebola project, they have their slides, and then there's the YouTube video as well. So we'll go ahead and go with an example here. Let's say you're trying to target a specific VP of eCorp, and through OSINT you discovered that he uses Microsoft Project, and you know what Office version, so you know that file path will exist on the target. You also know that his username is JDoe. So basically the attacker is going to encrypt his payload so it only executes on that system. So first, the attacker would go ahead and create the encrypted data on his side. So you can't use that string as a key because you're going to need 32 characters. So you hash the key data and use the first 32 characters because AES encryption, 32 character key length. Then you encrypt the payload with that first 32 characters of the hash. Now that you have the encrypted data, you can create the keyed payload that you want to execute on JDoe's workstation. So basically you'll create functions on the host that will basically pull that key data out. So get the value for the environmental variable username, and then let's just get all the paths underneath C program files, all the recursive paths underneath. And then the payload, when it executes, it'll basically, you'll loop through every single thing underneath C program files, tack on the value for username, try to decrypt. If it doesn't work, it'll just move on to the next one. So what that would kind of look like is, let's say application verifier is the first folder path underneath C program files, tack on JDoe. If this was executing on JDoe's workstation, try and decrypt, doesn't work, keeps bumping down the list until you finally find the Microsoft project file, hash that with JDoe, use the first 32 characters, it decrypts and executes, and the decrypted payload works. So that's kind of keying in a nutshell. The information disclosed in the final payload is the methods to retrieve the key values, but not the actual values themselves, and obviously not the original payload. The main takeaways here is that payload's very target specific. It's not going to execute in VirusTotal or any sandboxing. It might even have difficulty in the incident responder system. And then also from an attribution perspective, which is kind of interesting, if you sent that same payload to all VPs of eCorp, or say all VPs of the Fortune 50 and eCorp, it would be difficult to attribute who the actual target was because it's only executing on the one person that you were targeting. So I think a necessary discussion with keying is kind of around compiled versus scripting. So Ebola outputs to a compiled binary generated from Python or Go, which is really ideal because if you execute a binary, some .exe file, and it does nothing, well, then you're going to have to figure out, you're going to have to pull out some analysis tools. You might have to pull out some reverse engineering tools and figure out what's going on. And then you might determine that keying's in play. Then you might have to, so you have to keep going down that road. Where if you're keying a text-based payload, like a C# or a JavaScript payload, it's pretty obvious right away, if you're not using any obfuscation, that keying's being used. You can find the encryption functions. So, taking that a step further, if you saw that in a PowerShell script, that you were creating a keyed payload and basically decrypting on those 3 environmental variables, well, and you saw it was sent through phishing from the blue team side, well, you could just go on each one of those systems, pull those environmental variables down, try each one until the payload decrypts, and you'd have that decrypted payload. If you found it has persistence, it would be even easier. You just go to that system that has persistence on, pull those environmental variables off, and you'd easily be able to decrypt that payload. So this is kind of where you got to add a little tomfoolery in there. So basically, we're going to get all the combinations of username, computer name, and user DNS domain. So from those 3 values that was really just looking like one key, now it turns out to those 7 possible keys. And what's really nice is you can use blank values. So let's say I only knew the username and the computer name, but I did not know the user DNS domain. I could just encrypt those 2, but blue team would think I encrypted with all 3. And this is a really, really, really bad example. But if eCorp saw this, payload that was encrypted with 2 environmental variables, getting the time, getting the SID of the user, and getting the IP address of some host name, You're basically sending them on like an Easter egg hunt because they're going to have to track down all those things to hopefully decrypt the payload, when really the attacker just knew the username and the SID of the user from something and basically only used that to decrypt. On top of that, you can just throw in a bunch of bogus information. I mean, we're getting the host name of internet.tesla.com, so maybe eCorp would be like, well, maybe this target wasn't even for us. We don't have that host here. Maybe they were targeting Tesla. So kind of building on the combinations idea, I built a tool called Keyring. And what I really like about it is allowing for more custom keying functions. So sometimes, you know, when you're doing OSINT, you might not find the information that you could use for like Ebola. I wanted to make it a little bit more efficient and fast for red teamers to get creative, create their own keying encryption, decryption functions, and not have to worry about the encryption itself. Currently it supports C#, JavaScript, and PowerShell, and I just feel like I should note that the JavaScript uses self-contained COM objects, not .NET to JScript, so you don't have to worry about any signatures around that. There is some vocabulary. So a keying function that returns only one string would be called a combo. So that would be like your environmental variables. And then your keying function that would return a chain, like a string of arrays, one or more strings, would be called a chain. So that might be like your directory listings. And currently, Keyring supports one chain and unlimited combos. Kind of how that decryption process would look like. Basically, it just builds two arrays, and then we basically just add on all the combo functions. Then we generate all combinations, so you know we get that longer list of possible combinations. And then we add our chain as well. So in this example, we're using get running processes. So basically, we're just running through, you know, for each running process, we're going to try each combination and decrypt each time. And if none of it works, we'll just move on to the next running process, try each combination, and you know, until it either finds it or it doesn't. You know, this is a good point to just talk about some keying considerations. You know, more combinations, larger chains, you know, more possible decryption values is going to be longer execution. The CPU may spike. They might even hear fan noise. But on the other hand, it would be harder to determine the final key because there's so many possibilities the key could be. So that's just something you have to consider when you're building these payloads. Go with something you're comfortable with. So we'll just go ahead and do a quick Keyring demo here. Everything's going live here today. Wish me luck. All right. So everybody can see that, I hope. Yeah. So I basically built Keyring. It's very similar to kind of Ebola. It's config file based, and I'll hop into that in a second. And I also kind of built it around MSF Venom. So basically, what I like about MSF Venom is you just run a simple one-liner and it generates a payload, or you can just run other one-liners to determine more information to build the payload. So, for example, you can use like list langs, and it would show you the supported languages. But yeah, let's hop into the config file. We're just going to do a simple JavaScript payload, and kind of like I said, you know, it's very C2 agnostic. Doesn't matter what C2, but we're just going to use Empire since everyone's familiar. And then basically we just kind of add all our keys afterwards. So we're doing two environmental variable keyers, one based on the username, one based on the computer name, and then we're also going to do a custom chain. I'll show you that in a second, called get processes. So if we were taking a look at Keyring. So if you do list keyers, it'll kind of show you all the keyers that Keyring currently supports. So you know, it supports directory listing, environmental variable. So if we wanted to know more about the environmental variable, we could do help keyer. So it just tells you a little bit more, like what are the inputs, which is basically just, you know, the environmental variable name. And it's a combo function. So the get processes, so as you saw, or if you can see, you know, there's not a get processes keying function, but let's say we knew the target is running Cisco VPN AnyConnect, and we know that process is going to be in there. So we're just going to add that. We're going to add that function, but there's no supported keyer, so we'll use what's called a custom chain. Since it's a chain, it's returning one or more processes. We'll throw that in the config file. So just taking a look at it again. We have our custom chain. The only input would be the name of the custom function, and then that's the Cisco AnyConnect VPN process name. So at that point, we'll just point it at that config file. And it outputs it out to, it shows you the raw key, so the username and the VPN process. and then kind of gives you the final key hash. We're going to be using the first 32 characters is what would be used for the to decrypt the payload. And it puts it back out to result.js. So it adds in all the funky encryption stuff, combination stuff, and then as you see here, it just kind of has our build. This is where we're kind of building those arrays. So we're adding those two combos. Remember, we're just using username here, but it looks like we're also using computer name. And then we're adding the get processes. But because it's a custom function, it just throws in an empty function. So I've kind of already done the legwork there. Just went out on Google and found an easy JavaScript payload that would pull the running processes. So we'll basically you can just test it all you want. You see that it returns all the running processes. So we'll just go ahead and throw that in the clipboard. And then obviously we don't want to write it to the screen, we just want to return that array. So we'll just do return result, save it. And then, so this is a JavaScript payload. You could throw it in your HTAs or your SETs or wherever you want. We'll just for example, we'll go ahead and execute it just with C-script. So it decrypted actually pretty quickly, and we see the PowerShell executes. And then I'll just hop right on over to our Empire server here. Cool. So our Empire, it did end up executing and ended up calling back. And I'll just go ahead and kill it here. All right. So really simple example. Just kind of wanted to show how easy it is to just throw in a custom keying function that maybe the current toolkit doesn't support. So hopefully you guys can get creative and come up with whatever keying you guys want. But could this be better? Obviously we were talking about how the blue team could potentially decrypt the payloads. We also don't have a whole lot of control on when it is decrypting and when not. It would be nice if we could have a little bit of control. But can we improve this at all? And this is kind of where keying, where using remote resources kind of comes into play. So basically, if the payload's reaching out to some remote resource to get its key, and that resource is something that I can control, well then I can effectively decide when I want to send down the decryption key or not. So let's say with HTTP, the payload would make a web request out to a web server that I own. I'll either decide to return the key or not to. So that brings me back in control of when that payload executes and decrypts and executes. And basically I can turn it on and off. So this also isn't new. Back in 2015, Alex and Chris Trunser created an HTTP key module for Veil. And basically how that worked is it would basically beacon back to, the payload would beacon back to a web server, would grab the HTML, hash the HTML, and then try and use that as the key to decrypt. If it didn't work, it would sleep, and then basically make another request. And it was useful for getting around sandboxing. Unfortunately, it's no longer in Veil, and Alex's original blog post is no longer up either. So I kind of wanted to resurrect this out and kind of see where I could use it and how I could use it. The HTTP key again, and actually a key indication here on the slide. The key server domain is different than the C2 server domain. Obviously, you want to keep that C2 server domain close to the chest. We don't want anyone to know it. So you want your key server on a different domain, and then basically the payload, let's say, was encrypted with an HTTP keyed payload, makes a web request out, responds with the right HTML, hashes that HTML, uses it, and decrypts, and that C2 session establishes. But if you send back down some sort of benign HTML or it might look legitimate but isn't the expected HTML, nothing happens. It can't decrypt. The site2.com domain isn't shown up. And it's a good way to, obviously, if the defenders don't get that expected response, they'll never essentially be able to decrypt your payload unless if they're like brute forcing 32 characters. So DNS key works the exact same way. Obviously, you just have the payload make a DNS TXT request, get the response, hash the response, use that as the key. So use cases, similar to the HTTP key module for Veil, you could use it to get around sandboxing. You'd basically encrypt your payload. You'd set up your HTTP server to always send back that benign response. So you'd send the fish, wait an hour, the sandbox is going to be making requests, all these different analysis tools are going to be making requests. And then hopefully, after an hour, the user clicked on it, and it's been pulling back, the whole time. You replace that with the expected response. and the payload will execute, and hopefully, that'll get you around sandboxing. The way I use it a lot is I'll just keep the expected page up, let the payload decrypt, and immediately switch it over to the benign page. So that way, if anyone else tries to execute it, obviously it won't work. But an interesting side effect is you can monitor logs for those URLs or those DNS records, and if you see them being requested at a certain time, you might be able to detect incident response. So if your payloads might be executing when you're not expecting it to. So I figured some tooling around this would also be nice. Being able to turn keys on and off more easily. So I wrote key server. Basically, it just makes those DNS and HTTP keying a lot easier. You can turn the keys on and off. Greppable logs, you can see every single time a key's been requested. Alerts, so when a key's being requested and you're not expecting it, sends it to Slack or your email. And I also built it so I could still use those nice Apache mod rewrite rules. The constraints is my favorite piece with key server. So basically, it automates switching the key status. So let's say you have scheduled task persistence for 10 a.m. You could set the key server to only return with that valid response between that time interval, so that matches the scheduled task, and it won't ever execute other than when that scheduled task executes. Or let's say you had persistence in an auto run key. After it's been accessed once for the day, let's just automatically turn it off, and any other request that comes in the rest of the day, we're going to know about. Or you can automate that sandbox bypassing behavior by saying, hey, let's wait till the key's been attempted 20 times, and then we'll go ahead and turn it on. So I threw together code in Keyring as well. So basically, Keyring will generate the HTTP keying for C# PowerShell and JavaScript. We do DNS keying for C#. That's the only, out of the three, that's the only one I could do without spawning NSLOOKUP, and I just didn't want to spawn another process. So we can actually use pinvoke and some code to programmatically request a TXT record. Huge thanks to Arno and his DNS exfiltrator tool. And so DNS and HTTP keying are considered combos in Keyring vocabulary. So we'll hop into our first key server demo. So we'll go fishing with an HTTP key. A nice way to kind of save on infrastructure. You can throw your payload and key server on the same domain. Obviously, we still want to keep our C2 server on its own. So we'll do a phishing scenario that would probably work. Free tickets for DerbyCon. So it would basically make a request out to free ticks. And then after that, the payload's going to be making requests to Dave Kennedy trying to decrypt the payload. All right. Fake DerbyCon site here quick. All right, so I just just to save some time, I just threw up an HTTP key, similar to how I just explained. So it's off of Dave Kennedy. Shows that it's been accessed 0 times today. I'm not doing any alerting or anything crazy. If you wanted to see more information on it, you can just type info. So basically, I'm sending down this key.html, which is like HTML that includes a picture of Dave Kennedy, which will decrypt our payload, hopefully. It also shows you the hash of that response. So if you weren't using Keyring or something else, you could easily just grab that and use it however you'd like. And then there's obviously no constraints. So we'll take a look at the config file for that one. So I'm just going to use a C# Empire launcher, similar to kind of the first demo, just with C#. We're using this HTTP keyer, takes in a URL and the user agent. And then obviously that key data matches, that's the same FDF SHA-512 hash of before. But let's say you weren't using key server, you're using some third-party tool. Keyring can actually request and grab that hash for you. And I'll just turn that on. Turn on the key here quick, just so I can show you guys. So let's say you didn't have key server running, you can do dash request. So it'll go out and just make a request to some web page, pull down, and give you the hash. So if you didn't want to use key server, totally understand. You can still use whatever HTTP server you want. So go ahead and just turn this off for now. So and it shows up that one hit. So I already kind of set us up with our fish. It's going to be out to that free ticks URL. using click once. Anybody like click once payloads? I'm a huge fan. Basically, you only have to click once. Then this executes C#, so that should execute our payload here. And we're going to see that we're getting a bunch of beacons, and we're responding with off. So it's not going to execute. Empire hasn't received anything yet. So we'll just go ahead and manually turn it on here. And so quickly, it's pinging every 2 seconds. So we respond with the on, and then our payload calls back. So thank you. So the manual switching on and off is great, but what I've really been using this a lot for is IR detection. So basically, let's give this scenario. Let's say you've had some success. You're on a server. You're in memory with a high delay. It's calling back to some C2, but you also need persistence on a user workstation. Let's say you just used an auto-run registry key. So basically, we're going to use that. We're going to key to. We're using a DNS key. We're going to key to docusign.keyserver.site. So back over here. I'll just show you the config file for this one. So DNS keying, very similar, just takes in one input though, and we're just going to be using the docusign.keyserver.site. And then, I've already got the hash loaded in here. We got to hop into the. So again, to save some time, I've already thrown it in there. So we have our DNS key here waiting. If you show info, I'm just basically responding with some DocuSign GUID, something I've seen in other environments, so hopefully it kind of blends in. And then we have that hash of the response that matched the keyring config. But I did set up a constraint here. So basically, whenever it sees one hit, it's automatically going to turn off. So as you see here, it's saying it's active because of that hit limit constraint. So the moment that it hits one, it should hopefully turn off. So I just set up like a simple MS build payload. So just the C#, just threw it in MS build. So let's say you're executing MS build. And I should tell you, I actually set up alerts on this one as well. So I received the alert that says, hey, we just responded with an active DNS key to Slack. Key server says that as well. We should have our Empire payload. So our Empire payload's in there. And then if you see status, it's automatically been turned off to active. So let's say, for example, somebody maybe saw that payload for whatever reason, they're threat hunting or whatever. They caught that payload, they throw it on their own system, and they're either going to analyze it, maybe they throw it up on VirusTotal, but they screw up basically, and they execute that file again. As we see, the payload doesn't execute, and we get an alert that says, hey, an access attempt for that inactive DNS key. So we maintain access to that system, and now we know that IR detection's onto us, so maybe we can do something else on like that server, for example. So a good way to monitor for IR detection. Luckily, and this came in at the right time. I got caught doing this in the wild. So CodeInject basically sent out a tweet saying, hey, interesting file, this MS build thing. It's making a DNS TXT request out to some domain, some DNS server. I actually already knew about this because I was running key server, and I knew the exact time it was thrown on VirusTotal because I saw a bunch of traffic start hitting that key server. So nobody ended up getting like a custom implant I was using. And this poor guy that would talk, he was like, I just got my hands on it. The domain isn't answering anymore. I really want to see that decrypted dive function code. Does anybody have the response? And obviously, no one's going to have the response. And poor would talk. He's never going to get to see all the cool stuff I was using. But, I could have done better, though. That health services domain, I still lost that. Really can't use it anymore. So how could I do it better? Well, I could encrypt it with that DNS key and then then re-encrypt it with using like environmental variables and stuff. So that should keep like the Twitter guys at bay. And actually with JavaScript, this is pretty easy with keyring. So basically, you could create one config file that would take in that, that payload you're using, Empire, outputs it to some HTTP keyed file, and then your second config would basically take that in and then re-encrypt it with other things. Then you just got to run keyring twice, and you should have that doubly encrypted file. And not to brag or anything, but right now we're at 0, so on VirusTotal. But I'm sure that'll change, so definitely still want to look at using obfuscation. And just, this might seem obvious, but if the blue team found that DNS keyed or that HTTP keyed payload, and they blocked that key server IP or domain through whatever means, your payload's not going to execute, so don't get mad at me, but your decrypted payload's still safe. But just something to consider, HTTP and DNS keying is really useful if you have a couple methods into an environment. So as we get close to closing up here, I just kind of want to talk about some of my motivations and why and how I've been using keying over the past year or so. And I just really building on that SpongeBob slide, I just feel like the odds are really in the defender's favor. Like I'm going to get caught, and things like improvements to in-memory detection capabilities, finding things like create remote thread is getting a lot better. Finding abnormal binaries, making network connections, like sysmon event ID 3 is really good. Command line logging. And finally, these in-memory techniques and these red team techniques are finally getting the attention they deserve. And I really think that's because all tradecraft is about in-memory techniques. And Justin Warner brings up a really good point that the side effect of releasing tradecraft is funneling actors to predictable behaviors, and then that lures those threats to predictable detection points. So while we're all doing all these new latest and greatest things, it's basically pushing us all to try and do these in-memory techniques. So I went ahead and said, you know what, I'm just going to start dropping some files to disk. With keying, I feel comfortable doing that again. I might not drop an exe or a DLL right away, but dropping those different SCT or HTA files, I feel comfortable doing that with keying now. And this is where kind of obfuscation is definitely still needed. What I'll do is I'll typically obfuscate the original payload, I'll encrypt it, and then I'll obfuscate that encrypted payload just to make sure no brittle detections like detecting on certain strings is going to get me caught. And here's just one of my reliable go-tos that I've been using kind of on and off for a year that's been super EDR friendly. So basically I'll prepare some sort of C# dropper, and the implant overall will use the IECOM object that basically is programmatically using Internet Explorer and the Internet Explorer process to call back to different web servers. And then I'm going to try and get an HTA file onto disk. I'll use .NET to JavaScript to get that C# into JavaScript. And then I'll basically use keying to encrypt that output, and then that's what's going to be within my HTA file. Then I'm going to drop it to disk somewhere and try and find a way, some interesting way to execute MSHTA and then the full path to the file. And some advantages around that, like no network connections are being initiated anywhere besides Internet Explorer or Edge. MSHTA is assigned binary. All of the interesting stuff is still happening in memory. Everyone's looking for MSHTA with a URL from a command line logging perspective. Not to pick on MITRE ATT&CK, but if you just hop on their MSHTA page, the only examples they show are using MSHTA to retrieve a remote HTA file. And a bonus for me, I do like scheduled tasks, so it fit really nicely with scheduled tasks. But obviously, MSHTA gets a lot of interest, so just execution in and of itself may set off some alarms. So just some closing thoughts. Defense, I don't want to tell you guys what to do. You guys are definitely probably much more smarter than I am on the defensive side. And I think some of these recommendations are probably kind of elementary, but nonetheless, definitely want to understand the whole file's behaviors, maybe look for encryption-decryption functions, might give you an idea that keying is being used. You definitely want to be careful interacting with attacker infrastructure. Not that it might get you pwned, but it might set them off and understand that you're onto them. Along with running a file, with internet access, maybe want to look at using something like FakeNet to understand what network connections it's attempting. And I think we really need to start talking about whether we want to upload everything to VirusTotal. I know I'm always looking at VirusTotal, waiting for things to go up there so I know when somebody's onto me. So just something as an organization you might want to think about, how and when you're using VirusTotal. Kind of in conclusion, I hope that some of the use cases and some of the ways I've been using keying kind of spurs some interest from everyone else. Would definitely say to please key responsibly. Just been talking about hiding things from the blue team for 45 minutes or so. Obviously, after the exercise, we would still want to share those those indicators, those behaviors, and maybe even code, because at the end that's really what it's all about. So I do have some tools. They'll be up on GitHub here soon. I can take questions now. Yeah, definitely can take questions now, or you guys can catch up with me sometime afterwards. So any specific questions? All right. Well, thanks. This was a really good experience. That's all.